These are your linear equation and graphs with no context notes for the Overland Trail unit. Example 1. The Dingle family had 65 gallons of water when leaving Fort Hall, and they used 6 gallons per day. Write an equation for this situation and graph the data below. So writing an equation, we were told our starting point and our unit rate. So our equation would be y equals 65 minus 6x, or 6 times x, where y is the gallons of water remaining and x is the days since leaving Fort Hall. So to graph this, we have our starting point of 65, and every day we're losing 6 gallons of water. Once you have a series of dots drawn in, you can use your ruler, and we should run out of water on near day 11. So let's draw in our line. And I will adjust mine. No arrows are needed on this graph because we are not going to have a negative number of days or a negative amount of water. So we will have solid points on the y and the x-axis. Let's move on to example 2. Graph the equation y equals 4 plus 3x. So we do not have a story anymore. We are simply looking at the equation given. To graph this equation, we are going to decide what our y-intercept and our slope are. And so our y-intercept and slope come straight from the equation. Our y-intercept here is 4, and our slope, or our unit rate, is 3 over 1 for the rise over the run. So we are going to start on the y-axis at 4, and we're going to increase with a rise of 3 and a run of 1. And you want to plot at least 3 points to make a straight line. Grab your ruler and since we do not have context, you'd want to extend your graph through and your line should have arrows indicating that it is extending in both directions. On example 3, we have the equation y equals 10 minus 2x. So again, we're going to find our y-intercept of 10. And on this problem, our slope is negative 2. And I will write that as negative 2 over 1 so that I have a rise over a run. So again, we're going to plot our starting point first. In this case, it's at 10. And we are losing or falling 2 and going to the right 1. When you have a negative slope, you only move in one negative direction. down 2 and over 1 again. If I was plotting from here, I could go up and to the left to create a negative slope as well. Again, we have no context to tell us if this graph should extend on forever or simply only be in the first quadrant. So after you draw your line, be sure that your graph has arrows. All right. So what I would like you to do at this point is to hit pause, attempt examples 4, 5, and 6. When you are done with those 3 examples, hit play. All right, let's check and see how you did on examples 4, 5, and 6. On example 4, we have all 4 quadrants that we're graphing in. We'll notice that our starting point is at -1, and our slope in this problem is 2 over 1. So we have a positive slope of 2 over 1. So I'm going to go up and to the right. I also want to get a couple more points down here in the third quadrant. So I'm going to go down and to the left, and that still gives me a positive slope because down and left are both negative directions for slope, and a negative divided by a negative for rise over run is a positive number. And so again, once I have at least 3 points plotted, I will draw an arrow or draw a line with my ruler and have arrows on both endpoints. On example 5, we are starting at 1 for our starting point, and our slope in this case is 1/2, rising 1 and running to the right 2, falling 1 or running to the left 2. Once you have at least 3 points drawn, use your ruler and draw a straight line through your points. Have arrows on the ends. And on example number 6, we have a starting point of +2, and our slope in this problem is -3. When the value in front of x is not a fraction, remember we can turn it into a fraction by putting it over 1. So our positive slope of 2, positive starting point of 2, and our slope is -3 over 1. So we are going to fall 3 and go to the right 1 to start creating a negative slope. And I just have room for those 3 points, so I'm going to grab my ruler and draw a straight line through those points. And adjust it just a little bit. And arrows on my line. Let's keep moving on to example 7. Example 7, we are now transitioning and we're going to write the equation for the graph that's provided. So as I'm looking at this problem, or at this graph, I know that I need to identify a starting point. And this starting point I can see is on the y-axis at 40. I also need to locate another point that's on a perfect corner, and I notice a point here. And so I need to calculate my rise over the run. And so I notice here that I am scaled by tens, so I'm going to count up 10, 20, 30, 40. So I have a rise of 40 and run of 0 over to 5. And so 40 over 5 would be my rise divided by run, and that would give me a unit rate or rate of change of 8. So my equation here would be y equals 40 plus 8x. Let's take a look at the next 3 examples here. Again, I noticed that my starting point on this graph is at 20. And using the points that they already have indicated, I'm scaling by ones. I can see that I'm falling 3 and running to the right 1. Falling 3, running to the right 1. So my slope is going to be a negative 3 over 1. And so my equation will be y equals 20 minus 3x. Remember, you can write your unit rate first, and that equation would look like y equals negative 3x plus 20. These are both equivalent. I think that a lot of us lean towards writing our equation the first way because it is natural to write the starting point first because that's what you identify first on the graph. On example number 9, I have a starting point of 5, and another perfect corner doesn't occur until up here at the ordered pair 5, 25. So my y-intercept is 5. Now I need to calculate my slope. And so I'm scaling by 5s here. So if I calculate the rise up to that perfect grid point, 5, 10, 15, 20, and I'm running 5, 20 divided by 5 is 4. So my equation here would be y equals 5. I'm an increasing slope, so it would be a plus 4x. Or again, an equivalent equation would be y equals 4x plus 5. All right, example number 10. Looking again for that starting point, I see that I'm crossing at negative 3. And my slope, I found a perfect corner here and here, my rise of 2 and a run of 3. And it is up into the right. This is a positive line. So my slope is a positive 2/3. So my equation might be y equals negative 3 plus 2/3 x. Or again, you could start with your slope of a positive 2/3 x minus 3 for your starting point. I would like you to hit pause and attempt to write the equation for example 11 and 12. Once you have wrote those equations, hit play. All right, let's see how you did. So we first identify that starting point, and on this problem that is at 3. And you also need to identify the slope. So my starting point is positive 3, and my slope I can see is negative because the line is running downhill left to right. And it is a negative 2 over 1, falling 2, running to the right 1. So my equation might look like y equals 3 minus 2x, or y equals negative 2x plus 3. Last example, number 12, I notice that I have a vertical line. And if I remember my mnemonic device, VUX, V-U-X, that'll help me remember that vertical lines have an equation that only has an x in it. And so I notice that I'm going through 3 on the x-axis. So my equation is simply x equals 3. This concludes your notes over no context.